So we are going to discuss this thing here with Shrushti. So yes, Shrushti is here. Bhushan is also here. Shrushti, I'm going to add you on the stage. Shrushti, you are on mute probably. You are not audible. Hello, Bhushan.
Hello. Hi, Kunal. Am I audible?
Yes, you are audible, but I think your camera is off, and I think Shrushti is not audible.
Can anyone hear me?
Yes, Shrushti, we can hear you.
Oh, hello. Hi, Kunal. Hi, Bhushan.
Yeah, your camera is off meanwhile.
Yes, there's some network issues here, Kunal.
I understand, yeah. No worries.
Yeah.
So, Bhushan and Shrushti, stage is all yours.
Okay, perfect. Thank you so much, Kunal. Bhushan, do you want me to share my screen and then take it ahead?
Yeah, go ahead.
Please share. Yeah. Let me know once this is visible. Is it visible?
Not yet. Okay, something is loading. Okay, yes, it is visible.
Perfect. Okay, so maybe we'll quickly introduce ourselves and then we'll take it ahead. So thank you so much, Kunal, and thanks a lot for giving me and Bhushan the opportunity to at least share some information around the buzzword in the industry, which is AI, and what exactly AI can do, what you can do with agents. It's not just about retrieval, but more about it. So again, we have come here to speak around Agentic RAG, which you'll hear more going ahead. But I'll quickly introduce myself. I'm Shrushti. I've been working with Rapid Circle for more than 4 years. Also an MVP in M365 space, mostly for Copilot and Copilot Studio is my work area. And apart from that, also worked in Azure Power Platform as such. Over to you, Bhushan.
Thank you, Shrushti, and thank you, Kunal. Also, thanks everyone who has joined. My name is Bhushan Gawale. I work with Rapid Circle Solution Specialist in the data and AI. I am also a Microsoft MVP in the AI platform. I have played several roles in the past, right from the application developer, data platform engineer, now AI. And like Shrushti mentioned, that we have been doing a lot of work recently in the AI work stream there with a lot of different initiatives that we work for different partners, customers, and even internal initiatives, etc. So yeah, I think that's a bit about us. We can move on to the next slide.
Just a second, Bhushan. Give me a minute. I'll reshare my screen. There's some lag at my end. 1 minute, please.
Okay.
You can see my screen fine, right?
Yes. Yeah.
Okay. Let me know if there is any lag. Do you want me to mute till the time you are speaking? That would be better. Okay, it's fine. No problem. Go ahead, please.
Yeah. Okay. All right. So agentic retrieval and the powered by Azure AI Search, which is the feature that Azure AI Search provides. So we are here to talk and learn more about that today. So what we have done is we have tried to stitch this both experiences, right from the pro code side of things, to configure the feature, use the feature, and then extend that pro code implementation in the low code platform of Microsoft in the form of the Microsoft Copilot Studio, wherein the agent will be communicating with the pro code layer, and then that layer is responsible for leveraging the agentic retrieval feature of Azure AI Search, and then achieve a use case. We'll talk more about that as well in terms of how we have set, what is it that we have set, but then I think we can move on to a few fundamentals. The agenda here is, yes, we'll definitely dive into why agentic retrieval matters, what's the concept here, how it really works, what exactly that we have built, how we have stitched the code from the pro code side, like I was discussing. The demonstration of that as well, that Shrushti will walk us through. And towards the end, we'll talk about the best practices around agentic retrieval, what should be done, when it should be used, when it should not be used, what are the common pitfalls that we have seen while implementing this, and then we can, of course, do any Q&As at all if there is any option. For those who are not aware of concept of RAG, that is the common term now which represents your retrieval augmented generation. I quickly cover that. So LLMs are large language models. They are trained based on the certain data sets whenever they were trained in. So say, for example, the first LLM that came in was trained in June 2023. So if you ask probably a question to it, then if it has the answer to that, it will be able to respond to you in a very structured and well-formulated answer format. But then if you want to ask a different question, maybe it's beyond its knowledge, or if you want to ask a question that is relevant to your business domain or your problem statement, then LLM need not have answered that. In that case, what is usually done is the retrieval layer is written, through which you get to talk to the different data sets that you or your business processes may have. Once you query those data sets, you get those responses back. You then send those responses to large language model along with the original question that user had or anyone had. So what large language model then can do is, okay, this is the question. This is the chunk of the data that may contain this answer. So let me use both of these information and then generate the. So this is how usually the RAG technique works, where the G stands for the generation, which is where your large language model is responsible for generating the response. Retrieval is the information fetch, and augment is something that you're augmenting the retrieved information and the user context or the user question with the model. We can move on to the next one, Shrushti. So this covers the RAG part. Now, this has worked. This has worked well. A lot of industries, different implementations are using that very successfully. But then where it lags is sometimes your questions are really complex in nature. If you, even in general day, right? So when we talk to friends, when we talk to any human, we tend to ask a question in a format such that it comprises multiple questions in the single question. Yeah. So the other human, when it responds, then because of the natural intelligence that the humans have got, they usually break that question down and then try to answer you in a different, in a structured way. So the same concept here. So the industry has seen the success of RAG implementation, but then there was definitely a need that when they to increase the effectiveness of the RAG implementations by introducing a layer through which you can ask a very complex questions against your data sets. The questions may not have any relation with them, or one question may have the direct relation with the answer of the first question. So like if and else questions, yeah. So such a layer has been now introduced by Azure AI Search feature, Azure AI Search service, which is agentic retrieval. It's a multi-step process, and like the example that I gave, right? So it essentially as simple as breaking down the complex questions into subqueries, and then try to find the most relevant answer for those subqueries, and then towards the end, it consolidates all those answers of the subqueries and then produces a very fine-grained response for you. So it plans those queries, what exactly needs to be done, how that complex question needs to be decomposed. That happens in the plan phase. Now, who plans this? Is again the large language model is responsible for planning those questions for you. Because we are speaking of large language model here, and this is not the answer generation. This is the decomposition of the complex. So any model that is good enough to understand the complex question that can be leveraged here to do that. The retrieval part that I think we just talked about, so all those subqueries then are run in parallel against your data sets to find the right chunks or the right information. And then the final synthesis of the answers of those questions. Particularly because this concept is implemented as a first-class feature in Azure AI Search, it is implemented as a concept of a knowledge agent. Why this is because this knowledge agent then can just sit on top of your Azure AI Search index, which is the information store for you. And then that knowledge agent can be easily plugged on to the index, and then your actual upstream agent implementation can leverage that. So any query that user asks to your agent, that agent ensures that that query is passing through this knowledge agent layer before it generates the final answer. Again, you can turn it off if you don't want, but then you can turn it on as well. Conversation aware is, yes, so you can, because like I said, the whole point here is it's not just question and answer, right? So you have to ensure that you're maintaining the context of the conversation as well. Why you are generating this from story and then trying to fetch the answer. So that's fundamental concept. Let's dive in details of it in the next slide. So this is how the engine usually looks. So on the extreme left, if we begin reading this slide, so you have user query. This is where user is asking the question. We can feed in the conversation turns as well. So how many last conversations that you want to feed to your knowledge agent, so that your query planning then can become more effective, but because it then becomes aware of the conversation history and the context. So this is the query planning part. So query planning again is done using the knowledge agent via large language model. So once it decides that, okay, fine, so this is a complex enough question that I have to generate maybe 5 sub-queries on this question. So then those sub-queries are formed first. Then your retrieval cycle happens, which is when you are actually doing either the hybrid search or the vector search. When you do the vector or the hybrid search, typically there are certain algorithms that are employed there. These are like BM25 or RRM. So to ensure that you are getting the most relevant data sets for the answer. And then it also leverages L2. What L2 represents here is the level 2, which is the semantic ranker. So we'll talk more about the semantic ranker, how it works as well. But then in general, just assume that the L1 responses are good enough, L2 makes them best. Okay, so relevancy is matched, and then the relevance score is matched as well. And then the final responses are matched to the final response. And that's the extreme right side of things. All happens again via single element call. So there is no latency that gets added. Because of course, the first question that some of you might already be thinking is, hey, then if this is going through this lot of steps here, then what about the response time? Beauty of this is all these queries are for you. So there is this parallel execution engine that sits on top, and then it shows that that we can move on to the next one, which probably talks more about the concept here. Again, it's the same representation with an example. So someone is asking, say, for example, what is included in my Northwind Health Plus plan, and that is not standard. So as you can imagine the nature of the query here, which is complex enough. So first you have to know the answer, what is standard, and then you can only answer what is not standard, right? So this is where it decides to dig these into 2 subqueries. Then the retrieval is happening over the search index, then the activity log that shows you that what are the result sets that it has fetched while doing the hybrid or the vector search. And then you can configure this. Literally almost everything is configurable here. So how many results? So if you want to fetch only 2 results from the responses, you can do that. For this demonstration or for this example, the 3 is specified there. It also can get you the document references or the chunk references from where it has managed to find that data. So if at all any agent implementation, if at all you provide any citation for the responses, like show the document link, you can do that as well. Moving on. One. So how the semantic ranker works is, again, the concept is very easy. So L1 is get possible matches, which is what your AI search will ensure that. This is the service feature, so you don't really have to do anything. L2 is the another additional feature, which is understand meaning and then refine the order of the response. It's a paid feature, but then because I think agentic retrieval is in currently public preview, so you won't get charged for that. But then I think things will change. But then agentic the semantic ranker is a feature that usually the paid feature that sits on top of your Azure AI Search. As you can see the example here, so the query that we are asking, toddler-friendly movies about cats, right? So again, a complex question here. So you might get answers like, okay, these 3 are the best possible matches that could answer your question. What happens is when this set is then sent to L2 for, again, re-ranking of these answers, then it becomes context aware, and then your result ranking is refined there. Now, how this happens is L2 uses the Bing's deep search learning model there. to ensure that it is doing justice with the initial results that L1 has passed. And then the order of the better, basically your answers become better if you employ this feature. There is this semantic ranker score that you get to see against each of the answers. So it starts from 0 to 4 usually, the 0 being the worst quality answer and then 4 being the highest quality answer. So whenever if you play with semantic ranker, you might see answers like score, which is of say the aristocrats, the score is 2.14, and then the line we have less score than that, and things like that. So it's up to the developer then how many scores that it has to keep as a threshold and then pick those responses back. So that's the L2 concept that semantic ranker has, and then agentic retrieval leverages that. Moving on to the next one. Again, this is the same thing, but again, I will quickly cover that. So as you can see, the keyword results were received in the first retrieval phase. Then we have done the fusion RRF ranking because of the hybrid search that uses RRF as the algorithm. And then finally, on the extreme right, you are seeing the re-ranking with cutoff, the threshold. So we are only considering only 2 answers there to ensure that there is this accurate answer generation that happens in the last step. Moving on to the next one, Shrushti. All right, so I'll just give you a use case summary here, what we have tried doing, and then probably I'll hand it over to my co-speaker, Shrushti, who then can talk more about the update here. So the concept is very simple, that we have this, say for example, the common use case that we have heard is the insurance domain, where users may have a lot of different questions that they want to answer for, and then not everyone is really good at reading those complex insurance documents, so they are not probably aware of these different processes that every insurance company has, how to find it, how to file a claim, what are the documents that may be required, and things like that. Yeah. So we have tried creating an API layer at the top there, which is a code implementation that does the semantic agentic retrieval on the Azure AI Search service. We have employed the fast server there. Then the implementation is the stitch with Copilot Studio agent, and then we have leveraged AI services. That means you have Azure AI Search, of course, because that's the native feature of this, and then OpenAI models hosted in Azure, because the Pro Code layer makes use of that to ensure that the knowledge agent is functional there. And then the Copilot Studio backend as well. But then I think with that, I'll take a pause here. At this point, I'll hand it over to Shrushti to talk more about this and also demonstrate the use. Thank you.
Thank you so much, Bhushan. So far, I think just to summarize what we have understood is, just to summarize for everyone who is listening out there. So Agentic RAG is kind of, you can say, an addition or add-on to the normal RAG, whatever we were doing so far. You would have so far understood that why Agentic RAG is important and where it has to be used. So, okay, if I'm just using, if the intention of my agent is just to retrieve information from some document, and the nature of queries is going to be very straightforward. I mean, okay, fetch me the documents on how can I reimburse my claim, or something around that, then okay, you don't have to go and implement something called as Agentic RAG. So Agentic RAG plays an important role wherever you are going to use this in the use cases where you can easily guess that the queries would be complex in nature. And that is where the breakdown of queries will happen. The LLM will go and try to fetch the information. Not just that, semantic ranker will also provide the most relevant information from the same. So apart from, like, for each subquery, you'll get a response, you'll get the ranking score as well. And then after the information is fetched, you'll also run through another layer, and then the final information will be passed on. So this is where Agentic RAG is useful. But as Bhushan mentioned, so our use case is pretty simple. What we try to do is, we are working in the insurance. We just took an example of insurance industry, where me as a user who come in, and then I'm just trying to understand what all documents I'll have to submit. If at all I have insurances across all the domains, be it health, be it automobile, or something different as well. Now, it can be tedious activity because you have literally a lot of documents and knowledge stored. It's not just one place and all the information will be just grabbed from one place. No, you'll have multiple documents, multiple information about customers, and then whether that customer has already applied for a policy or not, if it is active, if it is inactive. So a lot of information goes behind the scene. And then you are also dropping in a complex query for which the Agentic RAG has to go and then fetch the information from multiple knowledges and send you back. send you back, right? So this is what we have tried to build. So just to give you the architectural overview, what we have built is API layer, as elaborated by Bhushan. We are using Agentic RAG, but that is built on top of FastAPI server, wherein under the hood it is leveraging Azure AI Search, and Azure AI Search is using the embeddings LLM model. So this is one piece. The other is you will just start asking in, okay, this is done. This is something from ProCode side. How can I go and integrate this into my Copilot Studio? So just to integrate, we have hosted this right now in web application, the server, the API is hosted there. And then we have created the custom connector to just go ahead and use that, the endpoint, whichever is hosted as part of web app. It is used or consumed as part of custom connector. And that custom connector is serving as now for me as a connector, which I can go and use in any of the ways, either it is Power Automate or any part in the Power Platform. So we just try to use that in Copilot Studio. And then rest is just the agent topic and the building of solution. So let's go ahead and take a look at it. Let me just stop sharing this presentation and I'll move to my demo screen. Zoom in a bit. Before I go and show you the Copilot implementation, I would quickly run you through the FastAPI server. So this is the endpoint which is hosted currently. And if at all I have to just elaborate in bit detail, we are just creating index. Everything is done from ProCode side. All the configurations to search, LLM, embeddings, everything is done from the code. We have loaded some data as mentioned about the information, like whether it is the customer information, the claim information, the knowledge of each insurance area, whether it is health or whether it is of type automobile, what all documents we need. So all those data is fed it. And right now our index and everything is ready. So if you look at the API, perform agentic retrieval, and if I just have to submit a query, just for your information on how that response looks like. So let me just zoom this so that you can see how the query is. So this is the query which I'm posting, saying that, hey, I got out of the emergency room with this much of bill. And my bill was for some suffering which I was going through, cold and cough. I think that is part covered in the health insurance, but help me out with the documents which I'll have to submit. And this is no longer needed, but just I want to show you that what we are trying to retrieve back. We're trying to retrieve back the different information like type, customer name, claim amount, policy number, etc. And as soon as I hit this execute button, let's just take a look at the response it is going to generate for us. Okay, it takes few seconds because I've not ran this for some time. Perfect. So now if you see that I just have got the response, and that response looks something like this. So this is my response, overall response which I've got. And what my assistant has shared me back is this detailed information about my claim. This is the assistant, what it does. This is what you have feed it the instructions with, the user data. And just to show you the difference between RAG and normal RAG, this is where it is important. So if you can see this number of sub-queries it has converted, because my query was a bit complex in nature. It was not very straightforward. So it has just converted to one sub-query, the second sub-query, and third. So this all sub-queries were broken down, and for each, it went in and it tried to find some information along with the references as mentioned. So this is how the agentic RAG is different from normal RAG. And if at all I have to weave this in any of the client, so currently the client for me or the UI user-facing interface for me is Copilot Studio. So what you can do is you can just plug this endpoint anywhere, just like I mentioned in a custom connector. But again, you can plug this in any of the custom websites as well. No longer you need to go to the Copilot Studio and do that. But the reason we are doing this in Copilot Studio is to show you the difference of RAG and normal RAG. If at all I post this query in the RAG and I want to retrieve the information, it will be very generic. It will not even provide me the information, the detailed information, the relevant information back. But with Agentic RAG, the endpoint does everything. So let me just go back to my Copilot Studio, and just to make you all aware that I am not using any LLM which is provided by Copilot Studio. So I'll go to the Copilot Studio, and all the knowledge is turned off right now, even generic knowledge and LLM responses. Yes, so web search is off, and if I go to the settings, there will be a generic knowledge. So just to ensure that we are only using Agentic RAG and nothing else. So even the generic knowledge is turned off, information from web is turned off. So now you'll be asking, okay, but Copilot Studio is already built on top of some model that can be GPT-4o, 4.1. How are you weaving this? So we have just to ensure that we only retrieve information from Agentic RAG, we have created a custom topic. So this is my custom topic, Agentic RAG. And what I'm doing here is I'm taking the query from the user, passing it to the endpoint, which I just showed you, and it is providing me back with the information, and then just doing some data layering on top of it. So let me just drop in a query which is similar in nature. Just copy that same query. Let me just grab this. Claim type, customer name. Okay, some information from there. Okay. The query is so big that I have to perform a lot of operations here. Okay. So now as soon as I hit the send button, you'll see the response coming in. So in the activity map, you'll also see a couple of other things, but I'll just wait on to the response and then we'll show you what we are doing there, because we are trying to also fetch information in some format, and hence a prompt and everything is used. But the information, whatever we're going to get, is similar to what we see in the response stream. So if at all, I have to scroll up. So this is the information. So it is saying that, okay, admin is asking for the information, and the admin display name is all this. It has an active policy. The status is active. The policy type is health. And then the claim type was emergency. Claim amount is this. Required submission. So whatever my query was, what are documents will have to submit? It is medical bills, doctor reports, prescription, all these things, along with the steps to file the claim. Everything I've got. And this whole information is exact same as what we are going to see in the response string of RAG. So I'll go back now. So this is the response string. Here it looks a bit long because
because it's not context aware there. When the query is fired using Copilot Studio, it knows the user. This is the direct query that we are passing in. That's why it doesn't have the custom.
Correct. Yeah. So if at all, thanks Bhushan for chiming in. Here I was not adding any information about who is requesting for it, while I can take that contextual awareness from my studio and I can get the user information, pass it on that, hey, admin is requesting for that. If at all I have to use the same query here, then I'll have to hard code that, okay, for admin, provide me this. Then it would provide exact same information, whatever we are getting there. So if at all I have to try for user admin, John Doe, provide the information, requested information. So now if I hit execute, let's wait. Perfect. The information is there. See, the exact same information given the context. So it is able to find the information, claim amount, same, please ensure all the receipts and documents are aware, all same response string, you'll get E1 here. So no LLM is doing any separate RAG. Everything is, we are fetching from the endpoint, and you can already see that in the activity map. So this is how we try to weave the Agentic RAG in Copilot Studio interface, because many of times what happens is being part of low code, because I've been working in low code for very long, we always tend to feel that, okay, we are missing out on a lot of things which can be useful, but this it's about integration, how well you can integrate. So you can already start in creating the Agentic RAG, the Azure AI Search. You can feed it with the index, feed with the data, and then you can do the pro code from the Azure side, and then just integrate, host it in the web app, and then integrate in the Copilot Studio. This is also what you can do if you want to really make this as part of Copilot Studio integration. It's not always about going to the pro code in Foundry and building that. You can also do it in Copilot Studio. While, of course, Foundry and building in the web application is pretty straightforward. But yeah, we try to build in Copilot Studio just to showcase that even we can integrate this as part of low-code platform like Copilot Studio. You don't have to do anything more fancy. Just integrate this as part of custom connector. So this was the intention of showing the demo. But now there is again one brilliant query which I think majority of you would have, that how can I go and start identifying whether this use case is for this use case will fit in the normal RAG or whether this use case will fit in Agentic RAG. So let me go back to the slides, and if at all you have any queries, maybe we can take that up at the end. But this is where I would like to pause, and then probably we'll talk about, oops, I think there is something wrong. Wait. Oh God. Okay, let me share my screen. So this is very important, wherein you can go and try to identify RAG versus Agentic RAG results comparison. So we just saw, right, what Agentic RAG did. And normal RAG, I think we all are very used to all the assistants, which just performs normal RAG. So where does Agentic RAG helps? RAG just helps to retrieve grounded answers from trusted documents, while Agentic RAG also adds reasoning, and it can also work on complex queries, as we said. And it is a multi-step questioning, wherein you are just breaking down your query into multiple sub-queries, and then it fetches you the information. And then again, on top of that, it does L1, L2, and then ranking is done, and then you get the relevant information. So this is like a complex planning goes behind the scenes, which we don't see, but behind the scenes, these things are happening, wherein Agentic RAG does go through the reasoning and planning, as mentioned. So you just need to ensure that what is your intent, whether you just want to find the information from your documents or the knowledge, then go ahead with the normal RAG. But if at all you see that your use case demands use case would demand something which is complex in nature, maybe the query is complex in nature, the data is stored in multiple in multiple ways, in multiple information, then you can just go ahead and implement and compare the results, and then try to see which one you want to go ahead with. And when to use what? RAG for simple fact-based queries, where speed matters, while Agentic RAG, when question needs reasoning, as Bhushan mentioned, that it is built on top of deep reasoning, the L2 layer. That is where the reasoning goes, the reasoning comes into the picture. Also refinement, because the semantic ranker will go and try to find the relevant information and not just provide you the information as is, whatever it is able to find from the knowledge. The refinement is also there, and deeper analysis, because it is built on top of deep reasoning. Cost, of course, RAG is faster and cheaper with minimal API calls, while Agentic RAG, we already saw that it breaks down into multiple subqueries, and how it does that, it uses LLM to do that. So hence the cost is a little bit higher, is more powerful, but it incurs higher latency given there are multiple steps involved. So little bit, few more seconds it might take, but it doesn't take a lot of more time. And how you can measure the richness? Brilliant question, wherein people go ahead and try to, they are very curious to know that, okay, I got the information, I got the response, but how can I check whether the response which I got was accurate, or whether it was relevant? Then there are different tools, and there are different ways in which you can go ahead and try to measure the richness and context or relevance of your information. There is an evaluators which you can go ahead and build, and there are multiple other ways in which you can go ahead and try to identify how was your response in terms of accuracy, relevancy, completeness, and clarity. So there are different ways, but you have to build that evaluators and then go ahead and try to implement that and see which one was more accurate in terms of whether it was RAG or whether it was Agentic RAG, based on the use case which you're trying to build. Okay, I think now is the time to go ahead and for you to go ahead and start building, if at all you're interested, and if at all you want to explore this. But before you go ahead and build, you also need to understand some best practices, and that of course there are some pitfalls as well. Maybe Bhushan, you want to highlight something around this?
Yeah, I'm not sure how much time that we have. I'll run a quick time check here.
We do have. Go ahead.
Okay.
Yeah.
Great.
We have around.
All right.
Yeah.
Sorry, Kunal.
We have around 10 minutes. 9 minutes.
Great. Perfect. So I quickly talk about the best practices and pitfalls based on the experience that we had while building this. Grounding, yes, it remains as a primary dimension here while you implement any RAG system for that matter, not only Agentic RAG. You'll always have to ensure that the way you are storing the information, the way you are creating your vectors, is formulated well. Why? Is because when the RAG happens, when the retrieval happens, the relevant chunk identification happens, and then because this is a search that happens in multi-dimensional space, you have to ensure that you have chunked your source documents appropriately, not too large, not too small, but then this the right size. Now, this right sizing is very subjective, based on the domain, based on the type of documents that you ingested in your vector space. So ensure that you have chunked those correctly. Also, if there is any labeling strategy that you have applied to those different document sets, like the actual document vectors, then do that, because when this information gets spread or stored in the multi-dimensional space, the semantic relevance is what will matter the most. If there is no labeling strategy, then there is no indication for the embedding model that these two information sets could be similar in nature. So it's usually best to do that, to ensure that when these information sets land in your vector space, they are somewhere relevantly close, knowing that you know that they are really close. So yes, your grounding strategy matters. So to ensure the accuracy or the richness of the response is higher. Then the balance part, when the retrieval happens, so you have to ensure that because you can get max or not max, you can get n number of relevant vectors from your vector database. Now this, we call it as a K usually. So these K can be configured as, maybe for every question I want 50 chunks, and then I'm just going to send those 50 chunks to large language model with my question, and then let the model evaluate that. Hey, can you then generate answer? But then it's too much of a work for model then in that case to go through all those different chunks. And then this is where again your chunking strategy matters. If you have set like 50 chunks, which are significantly larger in size, then that has a direct impact on the quality of the response and the latency. So you have to ensure that you are ensuring you are configuring the K such that you're fine-tuned to find the most relevant vector, say maybe top 3K. So only 3 chunks of the documents are sent to your model, and then model is responsible for looking into the actual data of those 3 different vectors that you have sent along with the question, and then it generates the vector response. This is where I think the K configuration comes into picture, and so you have to really pay attention to that. The last thing, observability. Of course, for all of this, you need to ensure that you have a robust observability in place. There are different Azure Foundry and Azure AI Search service observability capabilities that you can leverage there, which are as fine-grained as logging literally almost all the subqueries that are happening, the way the information gets retrieved, the tokens that are spent in retrieving that information, because this has a direct cost impact for you as well. So do that. So do configure observability for production grade solutions for sure. So these are the best practices. Now let's take a look at the pitfalls as well. Because now this is the first one, which is the missing or incorrect semantic configuration. This is very particular to the agentic retrieval. Why? Is because this is the primary component that agentic retrieval uses to do the A2 AI. Yeah? So we saw that in the previous slide. There is this configuration setting in Azure AI Search that you can do, which refers as a semantic configuration, where you get to define that which fields are of your interest when the actual re-ranking happens, and then what should be the sequence of those fields based on your schema of your search index. So you have to pay attention to that. Again, this usually is a iterative process that you do via trial and error. You begin with something that you feel is the most right, and then check the quality of response. If that doesn't match or doesn't sound like this is a fine-grained response, and you go ahead and reconfigure that to ensure that you're changing that sequence or you're changing that configuration to generate the most right or appropriate response for you. So do pay attention to that. Then now second is more relevant to the way this integration happens with the low-code systems. Copilot Studio is one of them. Because you usually end up employing some sort of connector or service that lets you talk to the low-code side of APIs. Then you have to ensure that the timeouts is honored there, because and this has a direct proportion with the payloads that your low-code API is emitting back to the solution. Because you still have to respect the boundaries of the HTTP as a protocol to ensure that you're not time it out. Again, very specific to this implementation, but then again, if this inspires you to build something similar nature, then yes, this is one of the areas that you need to pay attention. And then the last one is, I think Shrushti tried to cover that in her last point as well. The LLMs by design are not deterministic in nature. That means even if you're got the configuration correctly, You have asked the question, you got the response back. That response is good, but then the next time you ask the same question against the same setup and configuration, the response may differ slightly. So yeah, that non-determinism will always be there. But then there are ways, levers which you can control that. Not directly 100%, but then you can definitely tighten your implementation. And this is where evaluations play an important role for any AI implementation, to be honest. Not only agentic retrieval as such, even if it's as simple as any RAG implementation, if you're just building your own agent as well, which has nothing even to do with RAG. Still, I think it is always good to put those agents to the evaluation before you productionize them. Microsoft recently has also released the evaluator SDK that helps you do that. Maybe it's a separate session topic altogether, but then there are levers that you get through which you get to measure the groundedness, for example, how much of the information that model has used while answering your question. Then how much the fluency, how much was the fluency of the response, whether it matches with your threshold, things like that. So they also have some sort of simulators as well, which may make your job easy, so you don't have to create your own data sets of questions, for example. So these simulators can help you generate those different questions that are relevant for the data that you have stored in your vector data. There is this Azure AI Search simulator for the grounded for evaluation that you can leverage. But then yes, the message that we are trying to convey here is before you put any system in production, so it is very important, it is imperative that at least several rounds of evaluations to measure the quality and correctness of the response. With that, I think I'll again take a pause here. And probably I'm not sure if there is any question and answer that we have got. But resources and next steps, I think you can feel free to go and check out the resources yourself. To get started with the AI Search as a service and analysis to explore the agentic retrieval feature of this. Thank you.
Perfect. Thank you so much, Bhushan. Again, we'll just pause for a second and you can just go through Azure AI Search and then learn more about agentic AI solutions as well. But if at all you want to go and go to the Agentic RAG, I think there are a couple of videos from Microsoft Developer wherein you can find detailed explanation around Agentic RAG. And of course, this session, if at all it was helpful for you, maybe go ahead and start building if at all this made you a bit curious. And once again,
sorry, thank you. Before we go ahead, Q&A. So Shrushti and I always will be available to reach out on our LinkedIn X platform. So feel free to reach out if in case you need to bounce off any ideas. We'll be happy to help.
Perfect. And thank you so much once again to Purple Skill and Span Labs. Again, Krunal, really happy to be part of the initiative, which is 11-hour MCT Marathon. So happy to be part of it. And thanks again to all the sponsors and all the other co-speakers, whoever are going to go ahead and speak about some really interesting topics. Thanks a lot.
Thank you. Thank you so much, Shrushti and Bhushan. It was really an awesome session. I also learned a lot about search and retrieval augmentation. Thank you so much. I really like it, and I hope all of our viewers have enjoyed it. Yeah, thank you so much for being a part of India MCT Marathon.
Pleasure is ours, Krunal. Thank you so much for having us here. Thanks, everyone.
Thank you so much, Krunal. Thanks, everyone.
Thank you.